Alright, so in this video we are continuing to look at reflections in concave mirrors and finding their image. The main difference with this problem is where the object is, right? So our object in this case is between the focus and the vertex of the mirror, right? In our previous problem it was beyond the center of curvature, so it was off here. But in this case we have our object in between our focus and our vertex. And so we're going to be using the same four rules that we were looking at last time. So number one, any ray that goes through the center of curvature will reflect through the center of curvature. And so let's start off with this one. Now in this case, this ray is not literally going to go through the center of curvature on its way to the mirror, right? So our object is here, so our rays of light are going to go towards the mirror. But as long as that ray of light is lined up with the center of curvature, it will follow the exact same rule, right? So we'll have this set up. So our ray of light is going to go away from the center of curvature and hit the mirror, and then it's going to come back along the same path, right? So it's going to come all the way through here, through our center of curvature, back this way. Now let's look at our second rule. Our second rule states that any ray parallel to the principal axis will reflect through the focus. And so we're going to take our ray that is parallel to our principal axis, and then that ray, once it reflects off the mirror, will go through the focus. Right, so let's have this set up like this. It's going to go through the focus and off in this direction. Now, you will probably already be able to see a problem here, right? Once this ray reflects off, they start relatively close, but they get further and further apart as they move on. So on this left side of the mirror, these two rays are never going to cross. They are never going to intersect. So that means that we are never going to have an image formed on the left side of the mirror. So what we're going to do is very similar to plane mirrors. We're going to extend this line backwards into the mirror. So I'm going to take this reflected ray and just use dotted lines to go back into the mirror. And the reason I'm using dotted lines is because these rays do not actually exist, right? They, the image is made by our brain, but these rays of light inside the mirror don't actually exist. I'm going to do the same thing with this first line that we did. I'm just going to extend it back into the mirror. And we can see that these two rays, they cross just about here, right? I am going to do one more, right? In principle, we could just stick our arrow right here and be done with the problem, right? But I am going to just show one more just for the sake of showing a variety of the rays that you could have drawn. So let's look at rule number 4. Any ray that hits the vertex will reflect at the same angle that it has with the principal axis, right? So all that's saying is that this ray that hits the vertex will bounce off with the same angle. So let's draw that one. So this is the ray that's coming in to hit the vertex. And so now all I'm going to do is measure the angle that it makes between the principal axis and the ray. And so I'm going to take out my protractor, and I find that this angle is 10, 20, about 28 degrees, roughly. And so I'm going to make that exact same angle coming out on this end. So that's 10, 28 degrees is roughly there. And so this reflected ray is going to come off in this direction. And I'm going to do the exact same thing. I'm going to extend this ray back into the mirror with dotted lines because it is not actual light that's coming off into the mirror. And what we see again is last time, and sorry, this last one is a little bit messy, but as we see last time, all three rays are meeting in the same place. And so this is where our image is going to be, right? So we can just draw our image down to the principal axis. And what we see is that one, we're gonna be looking at our salt. One, the size, it did get a little bit bigger. So it is a bigger image. Attitude, it's right way up, right? This arrow is pointing up. So right way up. The location, I would say that it is inside the mirror, right? And also based on the way we've drawn it, it's also further from the mirror than our object, right? So it is a little bit further away, right? This distance versus that distance. And then the type. We've created this using dotted lines. So that means there are no light rays that actually exist here. So that means when we look in the mirror, anything we see is actually a virtual image, right? Our brain is receiving these light rays that are traveling further apart and is actually complicated enough to be able to stitch those together into an image, even though that image doesn't actually exist in real life. All right, so hopefully this helps figuring out how to find an image in a concave mirror.